Hi everyone, welcome to the fundamental online tutorial of DC Suite. In this video, you will learn how to set the physical parameters of fabrics in DC Suite and understand the properties and usage of each parameters. When you want to create a digital fabric, you need to understand that the draping and surface details are handled with two completely different mechanisms. The simulator reproduces the draping, and the rendered reproduces the surface details. In tutorial week 3, we have introduced how to apply surface details. Now, you will learn how to control the fabric simulation. So, let's start the lesson. You can control the physical parameters of each panel by selecting the panels. Then, setting the parameters values in the attribute window of physical parameters. DC Suite uses 13 parameters to define the physical properties of a fabric. In order to let you understand more clearly on the different attributes represented by each parameters, first, I create a circle panels with the diameters of 50 centimeters. And I put it on a model with a diameters of 18 centimeters. This way, we can clearly see the results of the drape caused by different parameter values. Density means the fabric's weight in grams per square centimeter. The calculation method is to take a square sample, measure the length of one side and the weight. Divide the weight by the square of length to get the density value. Remember that the units of weight is grams and the units of length is centimeter. When the density is higher, the weight of the fabric is heavier, so the fabric will look more draped, as you can see in the attribute window. The default value of density is 0.01. When I adjust to 0.001 and press simulations, the fabric floated because it's lightweight. Otherwise, when I change the value from 0.01 to 0.1, the fabric becomes more draped because of the increased weight. Stretch stiffness and shear stiffness controls the stretching abilities of the fabric. The higher of the value means the fabric is tougher to stretch along the directions. The lower the number, the more elastic it becomes. In DC Suite, U represents the directions of weft yarn. V represents the directions of warp yarn. And shear means the directions diagonally at 45 degrees. So, when I change stretch stiffness from 100 to 10, the fabric becomes more draped because of the increased elasticity. When I increase value to 1000, the fabric becomes stiffer. About stretch stiffness UV, we suggest adjusting values between 10 and 1000. For shear stiffness, note that this value is limited to 50% of the inferior stretch stiffness. Normally, it is advised to use 1/10 to 1/5 of the inferior stretch stiffness, which means that you can adjust it between 5 and 500. Bending is used to resist against the veneer bend and adjust the stiffness of fabric. When the fabric is stiffer and tougher to bend, such as denims and leather, it will have higher value. Otherwise, the lower the value, the more it becomes suitable for draping materials such as silk and knit. The bend stiffness for the weft and warp directions can be set separately just like the actual fabrics. We suggest that the adjustments range between 10 to the -5 and 1. Damping is the parameter used for dynamic simulation, which is to control the rebound speed of the fabric. The higher the value, the slower the garment moves during dynamic simulations, and lowering the value is going to cause the garments to bounce very quickly. UV and shear separately represents the rebound speeds of the fabrics in different directions. Besides, please note that these damping-related parameters do not work in static simulations. When the material is compressed in vertical directions and reach their compression limitations, they choose to be bent instead of to be compressed more. Buckle ratio is used to reflect the limitations under the certain amount force of compression. The units of these parameters is percentage, so the value will be between 0 to 1. The closer the buckle ratio gets to 100%, the more it becomes easily bendable fabric, such as silk and jersey. On the other hand, the closer the ratio gets to 0%, the more it becomes less bendable fabrics, such as denims and wool. Once the bending starts, the bent part, which is the corner of the fabrics, becomes weaker than before. The buckle stiffness is how much percentage of total bending intensities to use to decide the buckling stiffness of the corner of the fabric. This is used alongside bending stiffness UV. The multiple value of the two is actual strength of bending value of the fabric. Therefore, the closer the buckle stiffness gets to 100%, the harder it to be fold the corner of the fabric. Like knitted fabrics, it has better resistance in corners when it be folded. Otherwise, the lower the buckle stiffness, the easier it is to fold, such as woven fabrics or fabric with cotton composition. The friction coefficient affects the frictions between a garment and another garment. The higher the value, the more difficult it is to separate the fabrics. The panel can be made to behave like rubbers by setting its rubber U and rubber V parameters. As you can see in the slides, it is a 9-piece construction. Each panel has been set to be sewn together. In picture A, all the panels' rubber values are set as 1, which means the original scale. So it will be an identical scores panels after simulations. Next, in the yellow area of the picture B, We set rubber U to 0.5 and rubber V as 1 and press simulations. You can see the U direction's rest length is reduced to half of its original length. However, the V direction remains the original length for the yellow area. On the other hand, if we set the rubber U to 1 and rubber V to 0.5 for the yellow pieces, then you will get the results just like picture C after simulations. Therefore, the units of rubber parameters is percentage. 1 is the original length. This parameter can be used to make the detail of elastic garments. Next, I will use a project to demonstrate how to make a garment with elastic curve details. You can find the links of practice files in the information below. First, open our practice projects. You can see that this jacket has been almost completed except the curves. I want to make it into an elastic band style, just like the side hem. In 2D window, you can see how to deal with this type of details. It will be the structures of two pieces of panel seaming together. The outer panel is normal size. The inner panels is more made to reduce the size. You can see that the internal lines are added to the outer panels to enhance the effects of the wrinkles. Now, let's start the practice on the curves. First, go to the Show menus in the 2D windows and turn on the line length of measurements. Zoom in the curve panels. You can see that the sleeves is composed of 3 panels. The lengths are 5.31, 29.89, and 4.92. Add them up to approximately 40 centimeters. So, I need to create a panels of equal length with a width of 3.5 centimeters. Click the icon to create a panels, enter 40 in DX, and enter the 3.5 in DY. In here, positive and negative values represents the directions, and then knock them into a panel. Because this panel needs to connect the sleeves panels, I cut the line segments through the X divide line. There are 5.31 and about 30. And press enter. Next, press Ctrl C to copy the patterns and Ctrl V to paste it. This panel will be used as an inner panel. The other sleeves also needs the same operations. I can do it directly through Symmetrical Unified panel. Click on 2 curve panels, go to the Panels menus, and find Create a Symmetrical Unified panel. After confirming the selections pattern, press enter. You can see that the panels has been created within the green dot line. Then I will do 2D and 3D placements. First, move the panels to positions near the gray shadows of the avatars in 2D window. Click the Sync Panels icons to import the panels into the 3D window. Next, I need to bend the panels into crude shape. Go to the Attribute window to find the manual wrap functions. Change the status to Enable. Then use the ratio, top and bottom bar to adjust the degrees of curl of the panels. Usually, I will check the box and let top and bottom bar be adjusted synchronously. Then with ratios, adjust the small amounts at a time. After practice, you will be familiar with the operations. Because the inner panels will need to be placed inside the outer panel, so I need to roll the inner panels into a smaller circle. So select the inner panels on both sides. Continue to adjust through manual wrap. Then move the inner panels to the positions inside the outer panel. Make sure there is no overlap between the panels. Use the Rotate tools to move the panels to the appropriate positions. Do one side at a time. When using the Rotate tools, adjust one axis at a time. Turn the curved seams to the armhole lines of the sleeves to avoid panel twistings during simulations. And adjusting the tile. Same operations on the other side. Remember to select and adjust the outer panels and the inner panels together, so that you don't need to do the same things too many times. Then set the curves to Mode panel. The functions will remember the status of the current placements. In order not to affect the front-back panels during sleeve simulations, I set parts of the panels as freeze panel. Easier to select from the 2D windows. Remember to keep only the light on the Enable panel selections. After selecting, right-click on the 3D windows, freeze panel. Do the same operations on back panel. Next step is to set the sewing relationship. First, Move the curved panels under the sleeves panels so that you can see the sewing relationship more clearly. Go to the seam menus and find Create Merging Seam. When the sewing length of two panels is the same, we will use merging seams to sew. Due to the panels are synchronizations and symmetric, after setting one side, the other side will automatically complete the same setting. The sewing relationship between sleeves and curves will be more than one layers of panels, and the outer panels will be wrinkled due to the elastic band. Therefore, I will use attaching seams this time. Go to the seam menus and find Create Attaching Seam. Sewing the inner panels and the outer panel. And sewing the outer panels to the sleeve panel. Make sure that the sewings are displayed correctly in the 3D windows. Before simulations, you can change simulation qualities in the settings icons of 3D garments layers. Adjust the quality to low, which can help the simulation speed up. After the simulations, you can see that the curves are connected to the sleeves. Then we can set the physical properties of the inner panels to produce the effects of expansions and contraction. First, select the inner panels. Find rubber UVs in the physical parameters of the attribute window. We already know that this parameter is related to the percentage of length, and U is equal to the width directions. V is equal to the web directions. Now, I want to achieve the effects of tightness by reducing the length of the inner panels. Suppose I want to reduce the length to 60% of the original. That is, enter 0.6 in rubber U. Press Simulations. You can see that the top pieces is wrinkled due to the tightness of the inner panels. In this way, the initial effect is completed. Next, we can create some interior lines on the outer panels so that the wrinkles can be displayed better. Find Create Straight Lines in the line menus of the 2D windows and create several vertical lines in the outer panel. You can keep the lines vertical by pressing Shift. The densities and length of the lines can be freely defined, but remember that the lines cannot beam over the panel. Next, go to the panel menus and find Create Interior Line. Follow the instructions in the lower left corner. Select the panels to create interior line. Then select the lines. You can select them all at once. Press Enter to finalize. Then, only keep lines on the Enable Line selections. Use the Selection tool to select the lines. In Attribute windows, find 3D Activate in Line Informations and change to Yes. You can see the lines in the 3D windows light up blue. Represents successful 3D Activate. We can increase the values of crease stiffness. Then start the simulations. You can see that the directions of the crease will follow the interior line. You can also set smaller IVD values on the panels with more wrinkles to make the simulation results look more refined. Finally, we unmold and unfreeze the panels. Attach with the fabrics and finish this practice. We provide 54 presets of properties combinations. It is in the drop-down menus under Physical Parameters. With a single click, DC Suite sets the physical parameters values for you, which was determined based on experience. I used A-line skirts and hanging panels to show the effects of different physical presets. Note that it shows just the pure drapings, without any surface details. By adding surface details, the results can be made to appear more dramatic. Starting from one of the above preset fabrics, you can make further modifications to the parameters values until they produce the drapings you want. We can check the results with a few options. For instance, poplin cotton is a fabric usually used to make shirts. Its weight is light, so that it reflected in the density values. And since the composition usually is cotton, it can be easily folded at the creases. So you can see that the buckle stiffness value is only 0.2. For next preset, I choose standing row. You can see the band stiffness UV increase to 1.2 and 0.9. It means it has diverse properties. If I want to make it stiffer, I can just higher the values of band stiffness UV. Remember to press Enter after typing the value. Let's see the simulation results of chiffon silk. It has a higher mass and has a lower values of band stiffness. And the stretch values of the fabrics is low because it is easy to be stretched for well draping. We have known that based on the fabric presets, you can select any of them and slightly adjust the values. When you adjust the values of physical parameters, the titles of drop-down menus will change to custom. You can use import and export functions to let the settings out of these projects, then share with other projects. The export button is next to the delete button. Press the icons, enter the file names, and save it. You can see the type of saved file is DPP file. This is an encrypted file, so you can only use it in DC Suite. Let's go back to DC Suite. I can import the physics values through the buttons next to the export buttons. Press the icons, find the file you placed and open it. You can see that the titles of the values have just changed to the set of sample 001s. After importing, the settings will be placed at the buttons of the drop-down menus and only exist in these projects. You can also delete it by pressing the delete button. I hope you enjoyed this video. For more tutorials, please subscribe to our YouTube channels and see you in next time.